we'll let other people join as they show up. For those of you who have joined us on time, thank you very much. And welcome to another edition of the SBE Presents, courtesy of the CCBE. One point of note is that the next session is scheduled for the 30th of September. And when we booked all this, we didn't realize that that new federal holiday was also scheduled for the 30th of September. So we hope you'll still be able to join us, in the middle of your day's vacation, assuming, of course, the boss doesn't lump them all together at the end of the year or something. But anyway, hopefully we'll get to see some of you folks in a couple of weeks. And now I should just introduce John, who is, I find the right screen, our presenter today. John's had over 50 years of broadcast experience and best known for his twice-a-month workbench columns in Radio World. I'm sure some of you have read those. In addition to providing engineering tips, his columns have helped engineers perform their jobs with more efficiency. And he's been a major market chief engineer, run a contract engineering business with 7 employees, and now sells Axia AOP consoles for Telos. Actually, Telos Alliance, I should give the name correctly, sorry. A popular speaker at conventions, John is the recipient of the SBE Educator of the Year Award. He's a certified CPBE with the SBE and a member of the Society's Education Committee. So we're really lucky that the SBE have agreed to turn him loose on us. Thank you very much, John. The floor is yours.
Thank you. Thank you very much, and glad to see everyone here today. First thing I'd like to mention, 2 things, actually. If you have a cell phone camera, you'll want to have that handy because there may be some slides that you'll want to take pictures of for future reference. And the second thing is that if you're not receiving Radio World newspaper, it is free to those in the industry. And if you go to radioworld.com and search on the search block for subscriptions, they'll send you the information. You can get it either online or have a paper copy sent to you. If you're new to broadcasting and moving in the direction of broadcast engineering, you'll want this newspaper. It's full of a lot of good information and very helpful stuff for you to refer to, and as Harry said, to help you do your job more efficiently and get more things done. So I'm going to see if I can share my screen here now, and we'll get things rolling along. Okay, well, let's go to the first slide here. We're talking here about a basic review, kind of going through FM, and I will be presenting again on the 30th when you have your next meeting. We're going to be focusing on that more on AM. Today's presentation, though, is going to talk about some basics and then get into some FM transmitter basics. So, and then when Stephen wraps up the last presentation, he's going to get into a lot of RFR and issues with exposure limits and that sort of thing. So, hope that will give you all a little bit of a review of what's going to happen. But as we know, direct current or DC is steady state, and it's found in a battery. Our next slide shows what a graphical impression of direct current looks like. It's just a solid voltage that doesn't change, steady state. Okay, the next one. Alternating current alternates from positive to negative, as seen in the right image. So on the left, we're looking at DC, and the right, it's alternating current, and it is continuously changing. Next one. Alternating current, 2 of these alternations going from positive to negative and then back, or positive to 0, then to negative to 0 is considered one cycle. Go again. Cycles are measured in cycles per second, abbreviated CPS. And CPS, as we see here, 1 cycle per second is one positive direction, and then going in the negative direction, that is 1 cycle. It's also called a hertz. That is the more modern terminology. The next slide. How many cycles that we have here? The image at the left is showing 1.5 cycles per second, or 1.5 hertz. So we've gone from positive to negative to positive, and you see that there's 1.5 cycles shown in that image. Next slide. Let's try another one. How many cycles per second are shown at the left? A more modern term for the cycles per second is hertz. And in this case, we've got 3 hertz, 3 cycles per second. Next slide. The frequency spectrum, as the number of cycles increase, we enter the audio frequency spectrum, and it's generally accepted that audio frequencies run from 20 hertz to 20,000 hertz, and that's what occupies the audio spectrum. So as we are looking at frequencies, as the frequencies increase, different things happen. So this lower end of frequency spectrum is audio, but as we start increasing the frequency, we start getting into RF frequencies. Next. One thing, though, before we get into the higher frequencies is looking at household current. The frequency of household current is either 50 or 60 hertz, or 50 or 60 cycles per second, depending on the country. And this is called household current. So you can see, too, that the household current falls within the audio spectrum of 60 or 50 or 60 hertz. Okay. Household current is audible, and you normally will hear it as hum. Instead of a nice clean sine wave, in this image you see 60 hertz hum that is riding on the sine wave. So if you are troubleshooting an audio circuit and you hear hum, you know that it may be probably pointing to an issue with the power supply, that you've got 60 hertz or 50 hertz frequency on the audio, and that is normally indicative of a power supply not filtering the supply properly. Okay. The sidebar talks about how a power supply uses capacitors to smooth out AC pulses in order to form a DC voltage. Remember, the DC voltage was steady state, and DC voltage is what powers amplifiers. If the capacitors fail, 50 or 60 hertz hum can be heard, and this can also occur if you've got improper grounding. Okay. The frequency spectrum, as we go higher in frequency, we reach the AM radio band. AM stands for amplitude modulation, and this is a picture of the WHIO AM transmitting tower in Ohio. The AM band runs from 535 kilohertz to 1705 kilohertz. 1705 kilohertz is 1,705,000 cycles per second. So remember, we started out with 1 cycle in our first drawing, and we went up to 60 cycles, which was household current. And now with the AM band, we're talking about a frequency between 535,000 hertz, or 535,000 cycles, to 1705 kilohertz, or 1,000 cycles. This gives you a picture of the AM and FM bands as far as where they are located. You see, with FM, we're just going higher up in frequency. The FM band runs from 88 to 108 megahertz. Mega means millions. So 88 megahertz is 88 million cycles in 1 second. Okay? Here goes the frequency spectrum again. It continues to increase as we go up in frequencies. We hit to microwaves, radar, television, even X-rays. So visible light, as you can see here, even has a frequency. So the point, I think, for all of us to take away here is that you can take that one cycle that is 1 cycle per second, and you can increase it and keep increasing it. And as you increase, you get the frequencies for electrical service in your house. You get the radio frequencies, the AM and FM. You go up into TV, microwaves, radar, even X-rays. But as you can see here, visible light also has a frequency. So depending on where the frequency is, will determine whether it's a radio wave, a television wave, or an X-ray, or a visible light wave. Visualizing the spectrum, the radio frequency spectrum is shown below, and now you can see how important frequencies are. They really do determine what the transmitted wave is going to be, or how it is going to be perceived. When we apply an audio frequency to either an AM or FM carrier, it's said that we are modulating that signal. Hence the term amplitude modulation and frequency modulation. AM is known as amplitude modulation, of course, and with amplitude modulation, as we see in the next slide, the top waveform is the audio signal. It's a nice clean sine wave. The middle waveform is the AM carrier wave, carrier frequency. It's a much higher frequency. And then the bottom waveform shows the two signals that are combined or modulated. So as we're carrying the audio wave, when it gets to the receiver, the audio wave is stripped off of that carrier wave and amplified, and then put to speakers, and you're able to hear it. Here's a sidebar here that we talk about. Why do they call it a carrier wave? Well, whether it's an AM carrier or an FM carrier, its job is to carry the modulated signal to the radio receiver. The FM carrier, on the other hand, is not amplitude modulated, but frequency modulated. And in AM, the carrier amplitude is rising and falling, but in FM, the carrier amplitude remains constant. And as you can see here from the picture, the frequency is what changes. So as the wave gets higher in its amplitude, the frequencies go closer together, and as it goes lower, the frequencies get pulled apart. As we explore the FM signal, here we've got the FM carrier wave, the audio signal, and this gives you a better idea looking at how the frequency modulated FM signal is displayed. The effect of audio on FM: as the frequency of the audio wave moves in a positive or upward direction, the frequency of the FM signal increases. As the frequency of the audio wave moves in a negative direction or downward direction, the frequency of the FM signal decreases. An AM modulation review: in amplitude modulation, or AM, the amplitude of the carrier is changed. And then in FM modulation, the frequency of the carrier wave is what is changed. Let's take a look at how all of this is generated in the FM exciter. Both AM and FM carrier frequencies are generated by an oscillator. And just like an oscillating fan moves from one side to the other, a transmitter oscillator generates that station's operating frequency. For FM stations, the oscillator is located in the FM exciter, and the oscillator output is then amplified inside the exciter and provided to the output to be amplified further by the power amplifier. A sidebar here, in the early 1960s, there was a compatible stereophonic FM broadcast system. It was developed called stereo multiplex. This FM signal is compatible with both monophonic and stereo receivers. Stereo generator is used to develop this compatible signal. And so what it allowed was we could listen to a stereo broadcast, but if the stereo multiplex signal was not received, the mono signal would be heard, so the station would be able to be broadcast in mono, whether it was transmitting in stereo or mono. Here's a picture of the stereo generator. If the stereo generator is internal to the exciter, there is discrete left and right audio signals that can be applied, and the exciter generates the stereo multiplex signal. And we'll see that in just a moment. It's not uncommon to use an external stereo generator like this Omnia 9 SG. The stereo generator can be a part of the exciter, but it's more common these days for it to be an external device that feeds the exciter with a composite signal. Speaking of the composite signal, it's composed of the L plus R, or left plus right signal, the mono signal, the 19 kilohertz pilot, the left minus right signal, the RDS signal, or the SD and the SCA signals, if those exist. All FM processors made by Omnia can be used to generate the composite signal. The composite signal is composed of several components, as you see there to the left, and that's why we call it composite, because it's got a composite of several different signals. Here's a couple of pictures of FM exciters. They, again, are external to the FM transmitter in most cases. FM exciters, the older exciters, only put out a few watts, like 10 to 50 watts. Newer exciters may generate as much power as 250 or 300 watts, or even 500 watts or a kilowatt. And in many cases, they can be used as standalone transmitters. Most exciters include a test meter and a modulation meter, since they're actually generating the FM signal. And I'll stop here and bring up a real quick point that if you're buying an exciter, since this is where the FM signal is generated, you want to make sure that you put some money into this. The FM transmitter is basically an amplifier, a big power amplifier. But if you've got a lousy exciter to generate a lousy signal, all you're doing is generating and amplifying a lousy signal. So putting some money into the FM exciter makes a lot of sense. Let's take a look here at the FM composite signal, what it actually looks like. From 30 hertz to 15 kilohertz, you see the mono L plus R audio signal, and that's shown in red. At 19 kilohertz, we have what's called the pilot. And then next is the left minus right suppressed carrier signal from 23 to 53 kilohertz. The RDS signal shows up at 57 kilohertz, and then finally there is space for the SCA channels. If we look at this on an RF spectrum analyzer, the analyzer allows us to actually see the FM signal. And it's a helpful instrument to diagnose problems like spurious emissions or interference. But looking again, we've got the L plus R signal on the first left-hand side. That spike that's up there in the middle is the 19 kilohertz pilot. And then you have the 38 kilohertz suppressed carrier with the stereo information, and then the 57 kilohertz carrier and any SCA information beyond that. Looking at frequency agile exciters, most modern exciters today are what they call frequency agile. And this means that the FM center frequency or operating frequency can be easily changed. Older exciters used a crystal in most cases to generate the operating frequency and had tuned sections that were tuned to that frequency, which made it very difficult to change the frequency. So it couldn't switch to another frequency easily. You could go through and retune it all and make it operate at another frequency if you had the crystal for that frequency. But the new modern day frequency agile exciters that use just a rocker switch or a series of codes to set up the frequency is a lot more useful, because if you've got a station off the air, you can use just one agile exciter to get that station back on the air with exciter-only power. Boosting the power is done with this RF amplifier that I mentioned, which is also called the transmitter. You may see also something called an IPA. That's an intermediate power amplifier. So if you've got a very low power coming out of the exciter, it would go into an IPA to boost it up to maybe a couple of thousand watts, and then that power would then be boosted up to the 15 or 20 kilowatts as the output of the transmitter. It's important to consider safety first when you're dealing with transmitters, and keep in mind that even the RF output of an exciter can burn you. So you never want to remove the exciter RF connector on the back of an exciter when the RF power is on. In addition to the shock hazard, damage to the exciter may result, because when you pull that connector off, now the exciter is operating into an open load. There's no load holding the amplifier to keep it from running away. So it's a situation where you want to be careful that you don't have the exciter on and operating when you remove that connector. Here's a way to think about connecting the equipment. Just like sound amplifiers, they work best when they are operating into a load. An audio amplifier needs to have its speakers attached. That's the load. They're typically 8 ohms, but they need to have a load in order to operate properly. And the transmitter is the same way. Both the exciter wants to see a 50 ohm load, and the transmitter wants to see a 50 ohm load in order to maximize the transfer of power. Connecting the exciter, it's important that you use high quality coaxial cable for this connection. Exciters want to see a 50 ohm load, so use 50 ohm coaxial cable, not 75 ohm. Unfortunately, they both look alike, so make sure that you read the printing on the cable before you connect things up. Another point here to bring up is that the output for the exciter, being connected to your transmitter, you want to use high quality cable. Don't just use a piece of a cable that's laying around the station. Make sure that it's new, that it's high quality, with a good high quality RF connector, in this case a type N connector, connected onto it, because again, you're connecting the output of the station, the transmitted station, from your exciter to your power amp. If it's a lousy connection, you're going to have a lot of problems, and you don't want that. Another sidebar here, modern exciters are equipped with an internal harmonic filter, and this filter prevents unwanted frequencies, harmonic frequencies, from being transmitted and interfering with other stations. An exciter with such a filter can be fed directly into the antenna in an emergency, although you want to make sure that the transmitter will be operating properly, or the exciter will be operating properly, and you'll have reduced coverage using exciter-only power, but you'd be surprised how far even a 20 or 30 watt transmitter exciter can travel. Unwanted harmonics can interfere with other broadcast stations, and this is why you want to make sure that there's a harmonic filter on the output of the exciter if you're feeding that directly into the antenna. FM filters are also called cavities or resonators, and they attenuate the sideband energy. And the idea here is that depending on the number of cavities that you have, the steeper the notch, or the steeper the attenuation of those sideband frequencies. This is what an FM RF filter component looks like. It's actually just a hollow tube or canister that is open and empty inside. On the left-hand side, those white things that stick down in to the cavity are tuning filters, but there's really nothing in a filter. It's just a big cavity that is resonant to the operating frequency. And they are susceptible, though, to dings and dents. You want to be careful. You don't want to hammer them with a hammer or have something bang into them and dent them. That can cause problems. But this whole RF filter technology is really kind of a black science. It's pretty amazing. It's important that you match your equipment, and most exciters have a forward and reflected power meter. Maximum power is always transferred to the transmitter or to the antenna when the exciter is terminated in 50 ohms. That's called the load. If this match is incorrect, you'll get reflected power. And most transmitters and exciters have a means of tuning that reflected power out so that you get a minimum reflected power and maximum forward power. Most transmitters also have a reflected power meter to properly match the antenna. In some cases, though, this is an external forward and reflected power meter that can be used and is mounted outside of the transmitter on the way up to the antenna. Here's what I like to think about when you're talking about matching your exciter. It means no leaks. If you've got a garden hose plugged into a spigot and you turn it on, if the match is not perfect, you're going to have water leaking out of that hose. And that's what ends up happening with the exciter not matching properly to the transmitter, or the transmitter not matching properly into the antenna. What you want is what you see on the right, a nice tight connection with no leaks. If you have leaks, that's an indication that something is wrong either up on the tower or between the transmitter and the exciter, and it bears investigation so that you can try to make sure that the match is perfect. The FM receiver gives us both an L plus R and an L minus R signal that is fed into a matrix. The matrix then subtracts and adds the signals to give you discrete left and right signals. But if the coverage of the L minus R signal and pilot is impaired, only the mono signal will be heard, and that's the L plus R signal. So this gives you an idea of how we get the separate left and right signals on the FM radio, but also a mono signal. And it's also important for you to know that the mono signal needs to be there for you to hear when the L minus R signal is missing. Some things for you to check: reflected power is minimal, and that your forward power is at the licensed value. I've got a couple of other tips that are useful for you. I think the camera in your cell phone is probably the most important insurance that you've got around a station. Take plenty of pictures and keep them for documentation purposes. Your cell phone does a lot of things. Even it can serve as a remote control. This is the Nautel AUI that can show up on your cell phone, so you're able to actually see what's going on with the transmitter in a remote location. Another useful engineering tool is the Brother P-Touch. If you don't have one of these, it's, I don't know, under $30 you can get these and at an office supply store. And they're very helpful. As you can see, they're useful for identifying, making labels for the ISDN, if you're still using that. But here's another slick idea, and that is using the P-Touch to identify individual circuit breakers on an electric panel. You can also use the P-Touch to identify the transfer switch. So it's not just for wires or for electric breakers, but identifying the switch so that you know which position the switch is in and whether that's going into the main antenna or a dummy load or into an auxiliary antenna. Here's another neat idea, using the P-Touch to identify wall warts so you know which wall wart is going to which piece of equipment. And then over on the right-hand side there, identifying the AC plugs. So if you have to pull something out of a rack, you're not trying to search for the cable and find the right place to pull out, and you pull out the wrong cable and turn something else off the air. If you don't have a P-Touch handy, use gaffer's tape. This engineer used these to identify which air handler was which with the circuit disconnects. And then if you don't have a Telos Sharpie, let me know. I'll get one to you. But these markers are really helpful to label lines. So if you know which position your switch is in, but you don't know which line is which, marking it with a permanent marker makes a lot of sense. And this is also helpful if you've got an engineer coming in who's filling in for you, that he knows which one is plugged into what, and it just makes the troubleshooting system a little easier. While we're speaking about Sharpies, marking a satellite mounting nuts is also a good idea. I don't know. I guess it may not be quite so useful anymore with people coming in and having their sites fenced. They don't have the problem with vandals coming in and cranking on satellite dishes. But this won't get you exactly back to where you need to be, but it'll get you in the ballpark if you have the mounting studs marked like this. Consider adding a whiteboard panel to your office or your shop. This is a really neat idea for engineers to plan, schedule what you're going to be doing, draw schematics, figure out how something is going to go together. And it also is really good medicine for your general manager to see all that stuff up on that board. It's like, wow, this guy is busy. But Sharpies and whiteboards don't mix. And unfortunately, you may have had an experience where someone used a Sharpie on a whiteboard. Before you run off to Staples or Office Depot to buy that really expensive fluid that will take the Sharpie marker off the whiteboard, take the correct marker and trace over the Sharpie marker with the dry erase marker, and then just wipe it off, and it wipes right off. It's something that will have the salespeople indebted to you, because this always happens to the sales folks in their bullpen, where somebody will mark with a permanent marker, and then, oh no, how am I going to get this off? Come to engineering and watch engineering solve the day. It's important that you tighten electrical connections periodically. As you can see in this middle circuit here, the wires have actually burned because of the heat that has been generated by a loose connection. Infrared hotspots This infrared photography will identify the hot spots. This is courtesy of Richard Wood. What we have here on the left-hand side there, that is a bad bullet that is going to eventually catch fire. So having a tower crew go up your tower with a infrared camera, it makes a lot of sense. It's really good insurance. You can see where there are going to be problems before the problems occur. Here's another picture, a little close-up of the infrared photography that was done. Excessive heating here. We're looking at 34 degrees C or 98 degrees Fahrenheit with this bullet that is about ready to fail. Fluke has an infrared thermometer with models that run under $200, and this is a neat way of being able to monitor not only motors, as you can see here, but also electrical panels to make sure that everything is operating in the cool range. But if you've got a little more money, I really recommend that you pick up one of these. Fluor has this, it's called a One Pro adapter, and it plugs into your smartphone or your tablet, and it will spot heating problems, as you can see here. My friend Jeff Welton took a picture of me sitting on my computer, and you can see that it shows where there is heat and where there is not. The picture on the right is an electric panel box, and there is a breaker or circuit disconnect in there that has gotten really, really hot and is going to eventually burn. So you can have this, take it around to your station. You can charge other stations to make measurements. It even allows you to plug in a camera, a printer that will give you a printout or pictures, and it's something that can be very helpful around the radio or TV station. Fluke also manufactures a remote readout DVM. This is ideal for transmitter work, very helpful for putting the meter inside the high voltage cavity or high voltage component, and then being able to read the voltage from the outside. This next picture shows what's called an inspector. It's made by Milwaukee. You probably know those folks of making sawzalls and things like that. This is a little more expensive. It's $200 to $300, but it gives you a long cable with a camera that's lit on the end that allows you to stick that cable in places that you can't get your eyes into and take a picture of what's going on. But this is an even cheaper and easier system. It's a remote endoscopy for iPhone or Android. You can buy this little kit on eBay for under $20. It has a lighted camera at the end, and you can stick that camera in all kinds of places around the station, where there are places where you're not able to see with the human eye. This can give you a picture. If you're looking for parts, trying to figure out whether something is blown up, instead of you trying to stick your head in there or stick a cell phone camera in there, you can use this little remote endoscopy probe to give you an idea. A Fluke Volt pen could save your life, and if you haven't invested the $30 for one of these, I really recommend it. They're available on Amazon. The model number is there, 1AC-A1-11, and it's a non-contact tester that glows red when it's near the proximity of AC circuits. So you may have flipped a breaker and thought that it flipped and find out that it actually didn't. Before you reach into the transmitter and start doing work, you'll want to probe that with this little probe to make sure that there's no red indicator on the end of the probe, which would say that there is voltage present. A cordless LED trouble lamp is really helpful too, just because if you've dropped a trouble lamp and had the bulb break and not had another bulb to put in there, it's a real pain. These little cordless ones, though, are shock resistant. You can drop them on the floor. They won't break. They give you a really bright light, and they're available from Home Depot or Lowe's. If you haven't converted over to LEDs, it's a really good idea, and it's less operating cost, but it also gives you a much brighter light. And this is a demo that was shown at Batteries and Bulbs. You can see what the difference is in both cost as well as savings between regular incandescent bulbs, CFL bulbs, and then the LEDs. I like to show this to engineers to just remind them that if the office on the left is yours, you got a lot of work to do. Engineers are sometimes looked upon with disdain by management, and when an office looks like the one on the side there, the left-hand side, the manager is thinking, gee, is this guy really taking good care of my equipment? Whereas if they see a shop that looks like the picture on the right, they're a little more comforted that you're treating the facility with some respect. Found that you will earn more respect if your site looks more like the one on the right than on the left. Important for you to impress your manager with an organized workbench. What I suggest you do is come in on a weekend and spend an hour, throw away all those old cassette machines that are not going to ever be used again. Get rid of all of the junk that's around your site. The transmitter site is not a storage facility for junk. And unfortunately, that seems to be the thinking of a lot of management. The idea here, though, is that you want to have everything in its place looking real good. And as we wrap up here, there's another organized shop. Everything is in its place. All the parts drawers are labeled. You know exactly where things are. Real easy to find. If this program has been helpful for you, I hope that you'll let me know. My email is on here. I'd love to hear from you. Pictures for Workbench would be great, and they can certainly be presented anonymously if you got something kind of crazy to show. Also in Canada, that I'd like to recognize, since Tyler's on the call with us today, that Pippin Technical is available for support and sales of Telos products. We have a great relationship with them, and if you can contact Pippin for questions, they'll be certain to help you and assist you with Telos products or repair of the Telos gear. Be happy to entertain some questions if you all have them at this point.
I do have one comment, John, since you brought up Jeff's name. A label that you forgot to put on, because Jeff's first comment is always take the serial number from the back corner of the transmitter and put it on the front corner.
That's a very good point. And it is, in the case of Telos products, we are now asking that you register your equipment with us so that we have your serial number so we can contact you if there is a update or if we need to get back in touch with you. So I know a lot of times that gets thrown in the bin and forgotten about, but just as Jeff talks about how important it is to put that on the transmitter so you know where it is, we like to make sure that you have all of your equipment registered with our company as well as anybody else. I'm sure they're feeling the same way.
Does anybody else have questions for John? Oh. Well, hopefully everyone will be back again in 2 weeks. And John, very interesting. Lots of reminders, lots of hints and tips, and I'm not going to send you a picture of my workbench because it doesn't look like the one on the left.
Well, I think we all kind of get, I think that's a problem, Harry, is that in this day and age, we're running in so many different directions that it's easy to say, well, we'll get to that next week, and next week never comes. So, it's just, I guess, more of a thing to be aware of and to try to stay on top of little things like that before they turn into mountains.
It's like documenting the job, right? I got the job done. It works. I know what's there. You want me to spend the time and document, or do you want me to fix that other thing?
There you go. No, that's it. That is absolutely right. Well, Harry, thank you for helping with the slides, and I'm glad I was able to put this together for you guys, and look forward to seeing you in a couple of weeks.
Thank you very much, John. On behalf of the CCBE and our membership, it was very interesting, and we look forward to the 30th. Take care.
Very fine. See you then. Bye, folks.
Bye. And we will leave the bridge open if anyone wants to chat with folks they haven't seen for a while. We'll Sean will leave it up for a bit so you can say hi to your friends.
Yes, that's another thing. Thanks so much for everybody who attended, and we look forward to seeing you at our future training sessions as well.